Hey, welcome to the session Spatial Computing with Azure Mixed Reality, Digital Twins, and HoloLens. And so in this session, I'm going to talk about a lot of use cases. We're going to start with a digital twin use case. Then I will show you our volumetric video streaming solution called HoloBeam, and we will have a live demo even. Then we will talk a lot about Azure Mixed Reality services like Azure Remote Rendering, which allows us to stream and render huge polygonal models with hundreds of millions of polygons. And then we talk about an AR cloud implementation called Azure Spatial Anchors, which allows us to map the real world and, share and persist virtual objects. They are pretty exciting stuff. So a lot of stuff to cover, and at the end we should have some time for Q&A. My name is Rene. I'm Director of Global Innovation at Valarm Reply. And we do a lot of work in the Microsoft technology stack, ranging from the backend to the front end. So, Azure, and then, of course, data science and things like, of course, immersive, like the HoloLens. And we have been part of the HoloLens agency program, which is now called the Mixed Reality Partner Program. Since 2015, we're one of the first few agencies, and 5 years later, still living the dream, basically, and working a lot with HoloLens. But I've been doing AR and VR much before that already with mobile, the AR toolkit, I made a port of that. And so doing a lot of, community involvement, open source projects, blog posts, speaking at conferences, all virtual these days, of course, and, doing a lot of those things. And that's being honored by Microsoft with the Microsoft Regional Director and MVP Award, right? And I'm also an advisor for our beloved VR and AR Association, and so trying to help where I can, right? So let's get started and talk about some of the use cases. And like I mentioned, we will start with digital twins, and I'm pretty sure a lot of you are already familiar with what a digital twin is, but just want to make sure we're all on the same page here. And so let me explain it for a moment. A digital twin is basically a digital copy of a real-world entity. And that could be anything ranging from your organizational company structure, the hierarchy there, over to a building, or even just down to a certain machine inside a building or facility, right? And what you can see here on the slide, we have this jet engine, and then we have a 3D model of it. And so that 3D model is then enhanced with real-time sensor data coming from the real engine, right? So we have the real jet engine, we have a 3D model of it, and then we can visualize the sensor data on top of the 3D model. And that, of course, gives us much better context. We see much better, where is the actually sensor data coming from? Where is it related to, instead of having just to look at a control room panel, a table or something, right? So it's a great way to basically combine it with IoT, visualizing sensor data on top of a digital twin. And it could be a 3D digital twin, which we're going to talk about. It's a highly transformational market when it comes to IoT and digital twins. Gartner, the famous market research company, labels this basically as the transformational rating. It's the highest rating they have. And they basically say that, there's a lot of value in the market and a lot of money will be pushed into that. And we actually also see that when we work with our clients, there's a lot of interest and appetite for digital twins. So we built this solution for the Microsoft Technology Centers, the MTCs. And this solution is deployed in a couple of the MTCs worldwide. You can find it in every major country, or like on every continent you have an MTC, which this solution is actually running. And so our digital twin solution is basically showing a digital twin of a chemical plant. And here initially you can see the lady wearing a HoloLens placing this 3D model of this chemical plant, a digital twin of that chemical plant in her space, right? And what we also visualize here is these sensor data, right? So you can see these little sensor boxes over here, and here you can see the sensor reading, right? So in the real chemical plant, basically, you have all these sensor boxes that are providing sensor data for, the different devices there. And we can visualize that in a custom dashboard, temperature, humidity, pressure. That's what the sensor box currently is capable of, but it could be, of course, other sensor types as well. And so we can visualize the sensor data as it is in the context of the real chemical plant, right, on the digital twin of the chemical plant. So we know, okay, this is the sensor box, right? And there's a second part to this experience where we're using a digital twin of the sensor box itself. So you can see the sensor box on the bottom left there. It's this real bluish thing, which she's opening right now. And what we show there is a digital twin. You can see it here, a holographic overlay basically of the sensor box. that provides you training instructions, how to repair it and how to, fix certain issues. And, it's great for training as well. So, real-time insights from the real chemical plant, plus, of course, training instructions and other many more use cases. All right. So let's talk about another use case, which is our HoloBeam, a 3D immersive telepresence solution. So what we can do with HoloBeam is we can basically stream holographic volumetric video from point to point. And for that, we're using a 3D camera, a depth camera like the Azure Kinect, that is not just providing us the color information like you can see here from the webcam, but in fact also the depth data, the distance to the objects, right? And what we developed with HoloBeam is a solution that allows us to basically package it up and stream it just over normal internet connection using 5 to 10 Mbit with full HD. And so what you can see here in the video, that was actually shown in Satya Nadella's, Microsoft CEO's keynote. They shown our solution, right? And here you see a typical meeting room setup, and the lady is wearing a HoloLens, the two other people are looking on the big screen, and what you can already see maybe is this holographic gentleman. And of course, he's a real person, but he's not physically present in the same room or in the same building, right? So he's in a whole different setting. And with our solution, HoloBeam, he's sitting in front of such a 3D camera. We package up the streaming data, the color plus the depth data, stream it real time to the HoloLens, and then we can reconstruct a stereo 3D point cloud in real time, which is already pretty cool, right? But we can do even more. So what you can see now as well is this 3D building, right? So this is if we can bring in 3D models. In this case, it's actually, again, a digital twin. And so these green sticks there are basically temperature sensors inside of the building. And so they allow us to basically, visualize the temperature sensor data and talk with a remote expert. So think about this gentleman as a hologram there. He's a remote expert, architect, thermostat company, whatever, and they need to solve the temperature issues in that building, right? So he cannot travel there these days, but of course, we can have this kind of solution where he can still be, almost like physically present there. And since we're not using avatars, but real 3D volumetric video and synchronized coordinate spaces, we can actually have people, point at stuff and showing certain things there. Alrighty, so now it's the big time for the demo. So what I'm going to show you is a new solution we're developing where, if you don't have such a device like the HoloLens available for viewing capabilities, we're also thinking about other approaches. And since, a lot of people are using this typical video streaming and meeting solutions like, Skype or Teams, what you can see here now on my screen, or, Zoom and so on, right? We figured, okay, let's go where the people are and let's have a HoloBeam virtual bridge. So what you can see here is the devices setting screen of Teams, on my Teams call here, basically. And I can select different cameras I have here on my device, right? And look at this. We have a HoloBeam bridge right in here. And that is pretty amazing because this allows us to basically bring in HoloBeam content, bring in the HoloBeam rendering into any meeting solution, right? Your favorite meeting solution, if you will. All right, so let me switch to the HoloBeam bridge here, and now you can see my HoloBeam view. There it is. And let me actually move the microphone out of the way so that it's not like in front of me. But yeah, as you can see, full 3D environment. This is HoloBeam running right here. And I can also interact with our nice UI. And of course, as you can see, it's really 3D, right? So you can see me in 3D here. And again, I'm just, having part in a normal online video conference, a 2D video conferencing system like Teams in this case here. Like I said, we also have models. I can, bring in these models. I can, move them around, do other fancy things, and basically integrate HoloBeam if you don't have any like HoloLens tool, right? To get into still the meeting solution in a 2D fashion, kind of. All right, so that was a live demo. So let me quickly switch back to my slide deck over here. And there we go. Great, glad the demo worked. Let's get the microphone also back so that you can hear me a little bit better. Alrighty, so let's move on and let me show you something else. What you can see here right now is basically our HoloBeam solution running on a looking glass. And I guess a lot of you have already seen a looking glass, but if you're not, it's basically a volumetric light field display that allows us to see 3D content on a screen without having to wear any glasses, like no stereo glasses needed, and nothing like that is really needed. And you can just, wear your normal glasses like I do, or no glasses at all, and view the content. And, limited viewing angle, limited resolution with the looking glass, but really promising. And here you can see the Azure Kinect, right? That is basically capturing myself and then streaming that real time onto the HoloLens. Onto the looking glass, right? So we support multiple devices, HoloLens, other VR devices, looking glass, and also this kind of HoloBeam bridge solution where we can integrate it into any video meeting solution. We're also exploring a lot of things when it comes to AI and deep learning. And so what we did is we actually trained a deep neural network using depth data from a Kinect, right? So we can take the the depth data from the Kinect plus the color data, run it through a deep neural network for depth estimation. It will learn estimating the depth from the color data, and then we can apply it just here, right? And so what you can see here is this kind of a neural network running in the inference and evaluation phase. And so we can just give it a normal YouTube video, as you can see here. That's such an Adela, and we can project them using a depth estimation then on top of, in a 3D world. And that's great because, like, if you don't have 3D sensing camera like an Azure Kinect available, you can just use a normal webcam, right? And so we're experimenting quite a bit with that. Of course, quality is not, comes not close to a real depth camera, but, still promising in terms of the capabilities and, the reachability, basically, including more people that might not have a depth camera. So let's talk about another AI solution I developed using the HoloLens, right? So what you can actually see here is running a deep neural network on top of the HoloLens. So inside of the HoloLens, not any cloud connection. So here's what I did. I used Microsoft Cognitive Services called CustomVision.ai, uploaded a bunch of photos and gave them a label, uploaded another set of photos, gave them a label, and then basically trained a deep neural network using that super easy to use service. And the Custom Vision AI then provides you a REST API where you can then take a photo on your device, send it into the cloud, it will recognize it and provide you the label, the result. And there's another amazing thing about it. You can actually export these kind of models as a so-called ONNX format or ONNX. And that allows you to have this pre-trained model as an export, as a standalone export, if you will, and run it directly on the edge, on the intelligent edge device like a HoloLens, right? And so this is what you can see here. So I trained this neural network for object recognition.
This might be a car wheel 3.5 meter in front of you.
So it's going to output what it is seeing, basically, also with text-to-speech.
This might be a matchstick 1.1 meter in front of you.
And outputs also the distance. I'm using just the spatial mapping of the HoloLens here.
Minibus 3.1 meter in front of you.
Right, and as you can see, I trained some custom objects there.
This is likely a Volkswagen Multivan Generation 6 3.2 meter in front of you.
And to be clear, this is running real time on the HoloLens. There's no cloud connection needed, no internet connection needed. It all does the full evaluation on the device.
Likely a car mirror,
right? All is done on device. And so you might wonder, why would I need that? I mean, I know what a hammer is, I know what a power drill is. But think about, this could be specialized tools, right, that you want to train people on. And so you can, or think about, you buy a package at IKEA and want to assemble that, and you just look at the package, for example, it will recognize what kind of package that is, and then will actually show you holographic assembly instructions on top of that. Super exciting. This is using Windows Machine Learning APIs or Windows AI, and that even allows us to run it on the GPU, hardware accelerated. And so here you can see on a screenshot some evaluations where I've run it on the HoloLens 1 on the GPU. It's 4 times faster than if I would run it on the CPU. And I also have it running on this guy here, the HoloLens 2. We're getting really to real-time evaluation, right? Super fast because I don't need to send any photos to the cloud. Great for shorter latency, but of course also, no cloud connectivity needed, which is sometimes an issue in these kind of facilities. All right, so let's talk about digital twins again, but this time about large-scale digital twins, right? And there's an issue we sometimes might have with digital twins when we need a 3D model basically of it, right? And so that can be a challenge. You need to have a 3D artist that creates you a 3D model, but typically you already might have a 3D model from a CAD department, from an engineering department that is using CAD tools like computer-aided design, CAD tools, and they already, kind of design every product, every machine in these kind of tools. And the challenge is, of course, if you want to render it on a device like a HoloLens or any other mobile device, these are typically way too big. So what you can see here in the video is a model with 18.7 million polygons. So that would not be able to render on the HoloLens, right? Where you can render around like 200,000 polygons. But Azure Remote Rendering is allowing us to basically render it remotely. And so here's how it works. It basically takes the input from the HoloLens, like the hand input, but also the head rotation and the position, right? The 6DoF tracking data. That is being streamed to one of these powerful Azure GPU virtual machines where a remote rendering engine is running, which is then rendering our complex model and then streaming the result back as a video for the left and the right eye plus the depth data to then reproject it correctly into your scene. And so you can even have, that's amazing, you can even have a hybrid approach where you have some parts of your scene locally rendered and some of them remotely rendered. And it even does the right job with the depth and the occlusion and all of that, right? Really amazing. And it doesn't even take a lot of bandwidth. So in my tests, as you can see here in the video, it took like 16, 20 Mbit, something like that. Microsoft recommends 50 to 100 Mbit as a good connection. But yeah, I mean, that's amazing because, 5G even works. But of course, with 5G, it's even better. A lot of future possibilities there. Think about the 5G tech like slicing, dedicated bandwidth, short latency. I mean, this thing will just fly, right? It's really amazing. And I can tell you, I was really surprised how well it works. They do an amazing job using some clever tricks with late state reprojection, warping, and so on to basically mitigate the latency you, of course, will have if you're doing remotely rendering, right? And so here's another example where I took not a computer-aided design model, but a photogrammetry model, right? And photogrammetry is basically a technology where you can take hundreds or thousands of photos of a certain object from different viewing angles, run it through a program like reality capture, which will then output a point cloud in the end of 3D model. And so what I did here is I used the model I got from Sketchfab. That's a few millions of polygons. That's from the Pincio sculptures in Italy, where we unfortunately cannot travel again these days. Maybe soon, right? But anytime, this is possible to visualize it in AR, right? And I can use remote rendering. And that is also super interesting if we're thinking about digital twins, right? Because you might have a CAD model which you need to reduce typically, and that is labor intensive. But with Azure Remote Rendering, you can skip that, take the CAD model as it is. But sometimes you don't have even a CAD model available, and so you need to create one. And using 3D scanning technologies like photogrammetry or other solutions is, of course, providing you another option, and that's amazing. And again, with Azure Remote Rendering, I can render it as it is already on the device using remote rendering. Super exciting stuff. And that will also, of course, allow us to have, smaller form factors and lightweight glasses and that kind of stuff. So let's talk about the AR cloud, the augmented reality cloud. And I'm probably sure a lot of you know about it already. But basically, the AR cloud, the augmented reality cloud, is a solution that provides us a digital twin, if you will, of the whole world, right? So a digital copy of our whole physical world. And that allows us to then, with that mapping of the whole world, bring in virtual content that we can share with each other and persist it, right? And again, Gartner is also saying super transformational technology, highest rating, will have a huge impact in the industry, right? So there's a lot of companies working on it. For example, a few startups like, for example, Visualix from Berlin, or like 60AI, which this video is from, that was just acquired by Niantic. And then, of course, you have the big players like Google with Cloud Anchors. And then, which we're going to talk about a little bit more, is Microsoft's Azure Spatial Anchors, which at the moment is the only solution that provides you full cross-platform on Android, iOS, and HoloLens 1 and 2, plus true persistence, right? So then the anchors are not deleted after 24 hours, like your virtual, locations in the real world are not deleted. They will stay as long as you want. But so how does it work? So we have all of these mobile devices, right? And all of these people walking around, scanning a little bit of a room, creating a little bit puzzle piece of the digital twin, if you will, of the real world. And so in the end, the power of the AR cloud is taking these siloed experiences, taking these siloed scans, and sticking them and merging them together to have this full holistic view of this, in this case, the office building, which was, brought together all these puzzle pieces to create the whole puzzle. And that's amazing because this allows us to, go beyond just a sensor view of your own device, right? And so here's a sample using Azure Spatial Anchors where I'm showing basically sharing. And so what I did here, I basically created an anchor on my Android phone device. So this spatial anchor is basically a reference location in the real world, right? Then I uploaded that anchor to the Azure Spatial Anchor service, ASA in short. And what you can see here now is a first-person view recorded straight on the HoloLens. So the ASA anchor was then downloaded on the HoloLens that I created with the Android phone, right? I relocalized it on the HoloLens with its own spatial mapping, with its own spatial understanding of the world, and then it relocalized it and visualized it me at the exact same location, right? So it's really, we're talking about centimeter range precision here. And as you can hear, when I talk about centimeter range precision, this is not using GPS, right? It's not using Wi-Fi fingerprinting, Bluetooth, beacons, or GPS. This is using computer vision technology. Some famous algorithms like SLAM are involved, like simultaneous localization and mapping. And so, again, cross-platform shared Android, iOS, HoloLens 1 and 2, create an anchor on whatever device, upload it to ASA, download it on another device, and map it into the space, and you have the same reference location. Amazing. Sharing works, but also persistence. So here I was at the famous Pike Place Market in Seattle when we could still travel. And I placed an anchor over there with our company logo again. And then a few days later, I came back and, relocalized. And as you can see here, it relocalized in the exact same spot, right? And that is amazing because if you take a close look, the floor pattern changed, right? It was raining, then it dried up, a lot of people moving around. And so that's a super high challenge for computer vision algorithms, of course. But great job by the ASA team to actually pull this off, because this is exciting that it can relocalize even if there are quite some changes in the environment. Of course, it also has limitations, right? If you change the whole environment, of course, it won't relocalize, but these slight changes are just fine. All right, let's talk about some use cases. And one of them is collaborative design reviews, right? So as you can see on the screenshot, a lady, an education use case, we can enable these cross-functional teams with their own devices and, bring in whatever device they have and still visualize in AR the same content. So we're building an application called the Azure Spatial Anchors application, which allows you to basically do that. And we will release that rather soonish, I think, in the stores. But take a look at the video. And so the gentleman is scanning the space, getting enough information to actually create an anchor because they need some kind of feature points, right? Distinctive visual information. And now take a look at the lady as she's scanning around. She's now relocalizing the anchor that the gentleman created on his phone, which we can see the recording from. And so she has the same reference location then with that anchor. And what we also integrated in this application, which we have for iOS, Android, and HoloLens, is OneDrive. So you can take a 3D model that you put into your OneDrive folder and just, bring it into the scenery. And as you can see, we have the same reference location, but also real-time interactions. Now the lady's actually moving that kitchen sink. We're actually using Azure Signal R here for the real-time interactions, because ASA is providing us just the initial reference location, right? But the further interactions and so on, that's a different story, which you need to implement yourself. You can use different networking technologies for that. But anyway, it's exciting because we can share it and then we can even persist it, right? So think about this kitchen scenario. I can even persist it, bring back the kitchen model or whatever and show him our idea, right? Or think about professional scenarios where you're inside of a certain facility. I was at some chemical plants, and they're very dense, right? They already have a lot of modules and machine all over the place. And so they need to figure out where the machine fit in. And so they can use AR in real time and then even share it cross-platform and also persist it, right? Here's another demo I made using a 3D scan of, you will see what it is. But basically, I used a 3D scan to create a 3D object. So what I did here is I saved the session before, I saved this anchor before, and now I'm loading that anchor. So here you can see the anchor session I'm loading. Now I'm scanning around a little bit to get the anchor information, basically, so it can relocalize. And just after a few seconds, it relocalized, right? And brought in the 3D model I attached to that spatial anchor, which is super exciting, right? And so again, like I mentioned, I used the 3D scan here for the 3D object, and the real object, as you might notice, is on the right-hand side. It's the wooden Easter bunny here. And then I have a 3D digital Easter bunny twin that I created just with my mobile phone. And that's the amazing part about it. So I have a Samsung S20 Plus here, which has a time-of-flight camera, similar like the new iPad Pro. And so this time-of-flight LiDAR camera, there's, not the quality like in Azure Kinect, but, it's the same kind of technology. And so you can do 3D scans very easily, right? So for this 3D Easter bunny, I just walked around the wooden Easter Bunny a few seconds and had a 3D scan of it available, right? So we can use it to create these kind of digital twins super fast, even with mobile devices. We can share it, we can persist it in the real world, and that is amazing, right? So for example, my uncle makes these kind of wooden Easter bunnies, so I can scale it up, try it out, different scale, would it fit still in the house, and, let my uncle know, and he might build a new one, right? Wayfinding is also possible, super exciting use case, right? And so if I create multiple of these anchors in one session, they get connected with each other, so I can enable these wayfinding scenario. So think about a solution, where there's a certain failure in a facility, there's a lady or gentleman in a control room, they need to fix the issue. So they see a blinking LED, okay, machine XYZ is failing. What they need to do now is they need to typically, find the information, where's the machine, what is failing, and so on. Now imagine, a lot of paperwork involved, right? Now imagine we would enable them with these kind of modern technology, right? Where we can bring in these devices and, just use their HoloLens, put on the HoloLens, use a phone, scan it. It will recognize what kind of sensor is failing, and then load the wayfinding information using ASA and guide them, like showing green arrows on the floor, right? Overlaid an AR and guide them to the actual machine, and then they can fix it on site, even showing holographic repair instructions, right? Huge business value. Could save a few minutes, even if it's just seconds. As you know, if some of these facilities shut down for a few seconds, it costs hundreds of thousands of dollars or euros, right? So huge business potential. And here's another really exciting one that was made as part of the Microsoft AI for Good initiative. They have an app called Seeing AI. And as you can see, the lady here is blind. And this app, the Seeing AI app, is using AI technology and now ASA to help, right? And so what she's doing now is she will be using her phone to scan around to find the initial first anchor, and then it will guide her using audio snippets. Because these anchors are just reference locations in the real world, right? But it doesn't have to be attached to a visual object. It can also be a spatial sound object, which allows to hear where sound is coming from and, guiding to the real scenery. Yeah, super exciting stuff. Really love these kind of scenarios, when we can use modern technology, AI, and mixed reality or spatial computing in a general sense to build more inclusive and diverse environment, right? Where everyone can be part of and, participate. Super exciting. All right. With that, I say thank you. Thanks for your attention. We'll have a few minutes for Q&A now. But first of all, also feel free, of course, to reach out. You see my email here. You see my name. So please connect on LinkedIn. Also, Twitter handle is on the slide here. Yeah, so I hope I got some inspirational stuff over to you, which might help with your own project or, other things you're planning. But yeah, of course, also reach out to us, right? If you have any custom, development effort or something in mind, strategy consulting, we're doing all the things, down to the implementation phase, of course, as well. Yeah, but again, exciting time. We see sci-fi technology becoming a reality, right? For real. And that's really amazing, right? So thank you. Thanks for your attention. And please be safe out there. Talk to you soon. And again, I'm in the chat window answering any questions. Thanks and bye-bye.